This episode of the Troxel Podcast is made possible with support from ArchIT. Are you tired of standard IT services that miss the mark? Choose ArchIT for specialized, proactive IT management, BIM support, and robust data security tailored for architects. Whether you're a team of 10 or a growing firm of 50 plus, ArchIT understands the architecture industry and will empower your unique creative vision to enable you to do your best work. Embrace a technology team that enhances, not hinders, your design process. Visit getarchit.com for your free IT assessment and start transforming your firm and your tech experience today. That's getarchit.com. Welcome to the Troxel Podcast. I'm Evan Troxel. Before we get into today's conversation, if you are a regular listener and enjoy these episodes, please do this community a favor and subscribe both on YouTube and in your preferred podcast app. Your subscription is incredibly valuable in supporting what we're doing here to create this resource for the AEC industry. Being a subscriber, which is completely free, directly influences two things: my ability to attract sponsors that help keep this show going, and my ability to attract high-profile guests, which is great for you. My goal is to deliver quality episodes to provide value to you and the industry as a whole. So if you haven't subscribed, I encourage you to do so. As I mentioned, it's completely free and a great way to support the Troxel Podcast. In this episode, I welcome Mary Elizabeth Yarbrough. Mary Elizabeth manages the Technology Center in San Francisco and a talented team of research and design engineers working within Autodesk Research. She's been with the company for almost a decade and has worn many hats. Her background is in fine art, music, and furniture design, and she was an exhibit developer at the Exploratorium Museum prior to joining the company. I had the opportunity last summer to go on a guided tour of the Autodesk Technology Center in San Francisco when attending the AIA conference on architecture, and the tour was led by my guest in this episode. And as a maker myself, it is a pretty remarkable resource. So I couldn't wait to have this conversation. Today we discuss topics including the value of hands-on experience in understanding the transition from digital design to physical creation, the importance of making mistakes and learning from them in the iterative process of prototyping, creating, and manufacturing, the resident program at the Autodesk Technology Center, the importance of maintaining real relationships with partners, the power of curiosity and continuous learning, and more. This was a fantastic conversation with Mary Elizabeth. I think you're really going to enjoy it, and I hope you'll not only find value in it for yourself, but that you'll help add value to the profession as a whole by sharing it with your network. And now, without further ado, I bring you Mary Elizabeth Yarbrough. Mary Elizabeth, welcome to the podcast. It's great to have you.
It's great to be here.
So we were talking a little bit before we hit record here about my new digs in Southern Oregon. And one of the things that I have that I didn't have before is a shop. And one of my favorite books is by Matthew Crawford. It's called Shop Class as Soulcraft. Have you heard of that book?
Oh, but
okay.
Now I'm excited.
Recommendation
Wonderful.
for you. Yeah, it's about the value of blue collar work and just trade work, but working with your hands and the value that it can personally bring to you, meaning and value that it could bring to you personally, but also to serve, community and society. So I'm really excited to have this conversation with you today.
Me too. And this really resonates. So yeah. Happy to be
Awesome.
Here.
Well, my shop is not as cool as your shop. I've got the chance to visit the Autodesk R&D facility in San Francisco. Is it Pier 9? Am I recalling that correctly?
It's the Technology Center in San Francisco, yes.
Right. Technology Center in San Francisco. And wow, what an incredible facility. And you run that facility, and maybe we can just start there and give us an overview of what is encapsulated in that place.
Okay, wonderful. So I work for Autodesk. I'm part of Autodesk Research. And I manage the Technology Center in San Francisco. And I manage a really stellar team of research and design engineers. And the shops in San Francisco, we have a CNC shop with additive and a hybrid machine, subtractive and a hybrid machine. We have an additive shop. We have wood and metal for sort of back of house operations, and electronics. And so the work that we do in these shops, we work on Autodesk research projects, and we also support resident community. And what's really important for me as the person who manages these spaces is that they're really inclusive spaces, and for people who don't have a lot of experience with certain workflows, we really want to empower people to understand the way things are made. And one of the reasons the technology centers exist is to validate workflows from digital to physical. So it's really one thing to be able to, make a drawing. There's no gravity. You can do some simulations, but when you get into reality and you're dealing with physical materials, you're actually holding materials, or you see the actual scale in person. You have that tactility that you're talking about, getting your hands on things. Then you really start to understand the way things go together. And the shop in San Francisco, at the technology in San Francisco, is really geared more towards manufacturing. The technology center in Boston is more geared towards AEC space. So you might want to speak to my colleague Joe at a later podcast, because he has a lot of projects he could discuss there. But we're a network of technology centers, and the one in San Francisco, we have a Mazak machine, we have 2 Haas machines, we have FX20 Markforged in the additive shop, we have laser cutters, we have consumer, prosumer, and industrial machines. And the purpose of these spaces is to really, validate workflows and make sure people make data-informed decisions for their design, so that they design things more intelligently.
Everything that you just talked about is like hardware stuff. And obviously there's a huge software component to this as well. When you're talking about data, you're talking about validation. A lot of that can happen before you get to physically making, right?
Absolutely.
But there's a process there. And obviously Autodesk is a software company, right? So I think it's really interesting that Autodesk has invested into this program. And maybe you can just talk about what the residence program is, because I found that to be really interesting as well. You're obviously invested in this idea, but then you're actually picking partners to come in to collaborate with. And I would love to kind of get into the weeds about how all that works with their IP and their startup and whatever it is, but just take that and go with it where you will.
Okay. So first of all, we work with different resident teams, and we choose them because their projects are aligned with certain focus areas within Autodesk research. We choose them because we believe, through interviewing them and through their proposals, that they're going to be good members of our community. And there's a few that I'd love to highlight because they're just stellar teams. We're not as concerned with whether they're Fusion or Autodesk software users. That's not as important to us as what the project they're doing and how their project might push some research further. But all residents own their own IP. And if they want to tell stories, and like where we could help tell their stories, that's a real win for us. But we stake no claim on the IP of different groups. What they get from being residents is they get training on our equipment, they get access to the resident community. So there's fellow people working in different domains where maybe they could validate some of their assumptions or test their ideas. They have a community of people that they can meet with, that they sit with at the desks, and then they have access to the workshops, and then they have access to the expertise of all the research and design engineers who work in there. And it's residencies can be a few months, and some have gone on for years because they're really terrific residencies. And a lot of these people spin off into other companies. Sometimes residents meet each other and they're like, we should start a company, or, the combination is better than my piece and your piece. So, but we have a range of equipment in our shops. So we're not manufacturer, beholden to only one manufacturer. We're software agnostic. So we want to really be inclusive of all kinds of workflows because it ultimately makes our machines better and it makes our Fusion software a lot better. So if we understand where gaps and holes are, then we can, bring that back to the Fusion team and give that feedback. And then suddenly we have a new post for a new process that we didn't have before. So what we ultimately want is for people to become Fusion users, but sometimes they're not, or that's not what their training was. And so, but we don't turn people away because of that.
I think I remember you saying when you led the tour that I was on was that when residents come in, they have space that they can dedicate to themselves, but there's not a requirement to come in and work. Is that correct? Because I know there's a lot of big tools that are shared. There's workspace that's shared, but I assume that there's also some kind of like space that it just gets to be theirs because it's nice to go to a shop and keep stuff there on the walls or in the drawers or whatever and not have to worry about that all the time. Can you explain that, like the logistics behind that?
Sure. I should also say that the Technology San Francisco is literally on a pier. So we're over a body of water that also determines kind of what equipment we're able to have and what kinds of work we can do. And we don't have a lot of storage. We're on this long, narrow, footprint's pretty narrow. So we don't have a ton of storage. We need to understand what people's like artifact size or what the work envelope they need for their project. Some projects are construction scale, and we'll then say, hey, you should apply in Boston. That's a better place for you to be.
And that facility is a lot larger, right? I think
right.
I heard something like 3 times larger or something like that.
It's a lot larger, and they are doing different work. They have a lot of robotic construction projects, and they have, we have robots here and some industrial robots in the robotic space, but that's not a space that's open to resident work. That's more for robotics research. But as far as residents go, when we sort of ask them a lot of questions. What kind of tools and technologies are you interested in using? How often do you think you're going to come in? Do you just want to access to the community that way you can just sort of have a hot desk and come in when you want? The model, it really changed after COVID, I would say, because we had a lot of people who were working remotely and became really used to working remotely, and where before we had, the place was bustling with people. So now we have a few shop users who are heavily on machines that we've trained, and so we really trust them. But we don't have like, you dump your stuff here, you dump your stuff here. We just don't have the real estate. So we have to be really choosy and careful about where stuff is staged or, but it's all about communication with the residents and us. And so it's just constant dance. One of the residents I really wanted to highlight with you and I think we talked about them when you came for a visit, was FICOS. They're the ones who do the autonomous vessel. That
makes total sense, right? Because you're over the water, and it's like I was hoping you were going to talk about that one because it's an intriguing project.
But I want to mention them and give them a special shout out because they're such stellar residents. They're such incredible members of our community. They're amazing stewards of the shop. They're super conscientious. They've been mentors to other more junior teams who are doing other projects, who are, really accomplished in their own right. But the people of FICOS are just so, they just have a ton of experience that they've been able to share. And their project is, they're now on version 3, but the idea is they want to take carbon out of our oceans and have oceans that are, healthier and safer and better. And so they have made an autonomous vessel that grows fast-growing seaweed on the bottom of it. And they drive it around. It collects a lot of carbon. It ultimately gives itself a haircut on the bottom. And then that becomes a carbon sink that sinks, and it's a carbon sink for like 1,000 years. It has.
Wow.
Yeah. So it's all about carbon sequestration, but the why I love talking about them is because they're such wonderful researchers and shop users who really walk the talk of like kind of quick and dirty prototypes that are fairly advanced, but we have this idea. We want to make an autonomous vessel. Let's first use a paddleboard, put a piece of wood under there that's going to simulate the growth rack for the seaweed. And then we're going to ride it around on our paddleboard. They're really like fit too. So, you can just tell they're very comfortable being on the water on a paddleboard, cool. And then put a bunch of sensors on things, see how that behaves. Okay, now we're going to do a stack laminated vessel. We're going to put it on a CNC router. We're going to get all the approved chemicals that can be at the pier and coat it with the right make it watertight. Do all the electronics here. Now we're going to start driving it around, validate these workflows, get it in the water, find out what's going on. And then now they're doing a 3D printed hull because the version 2 was so kind of time consuming to make, even though it's still something they put out on the water. But now they're using one of our large scale 3D printers because it's going to be a lot more efficient to manufacture that. And so that's something that, the evolution is something that really happens naturally here with our residents, because them getting access to these tools and technologies, making things themselves, because we're not a service provider. We will give you all the information you need, but you're going to make it yourself. Mm-hmm. Once they start making things themselves and they see how laborious stuff is or how expensive it will be or how time consuming it is, then they start doing the calculations of how much that will cost to get it manufactured, writ large. Yeah, and they want a number of these vessels in the water. So now they're doing a 3D printed version, and it's working beautifully. So this is just I don't know, they're just a wonderful team, and it's just so amazing to see the evolution of their project.
That iterative process that they're going through right there on display, it's got to be inspiring for others who are also residents there or thinking about becoming, maybe people doing tours, things like that, because you do get to see. I remember seeing that the vessels went, the different versions of it, and I think that I think it was gray. It was a 3D printed hull. It looked like, and give people an idea of the size. I mean,
that's right.
Yeah, it's about 3 or 4 feet long.
That's
if
right.
I remember correctly. Yeah, so it's not small. Like when you say large scale 3D printing, it's not a desktop 3D printer doing this. This episode is made possible with support from Chaos Enscape. This is the perfect time to set good intentions and resolutions for the months ahead. Whether you aim to solve your design challenges faster, run your projects more smoothly, make quicker decisions, or share immersive walkthroughs with the click of a button, here's some good news. You won't need any resolutions. Chaos Enscape has the best 3D workflow solution. Chaos Enscape is the industry-leading real-time visualization plugin that is 100% fast, 100% easy, and fully integrated into your favorite design tools. It is the trusted choice of over 500,000 monthly users across 150 countries. Starting today, you can get a 20% discount on fixed and floating annual licenses. Just head to chaos-enscape.com and use code RES24 at checkout. That's chaos-enscape.com using code RES24 at checkout to supercharge your design workflow. Thanks to Chaos Enscape so much for their support of this episode. And now, let's get back to the conversation.
And I think this makes me want to mention something else just about like how we procure equipment here and how we get the equipment we have. It's not random. We do a lot of validation and user testing through the work of the residents and Autodesk researchers. And if these machines weren't in use by them and we weren't finding out what's working and what's not, then we wouldn't have the same equipment. So they started to use a piece of equipment that just wasn't working well, and it was having a lot of clogs, and there was just always issues with calibration. And so we started, because they were really using the whole print bed of that former printer, we looked into a different technology. And so I sent my additive SME to like a trade show for additive manufacturing, and she came back and said, hey, this one looks really interesting. What do you think about this? So we did a bunch of research, talked to them, And then we got this printer. It was one of these things where it was like flat packed and we had to assemble it ourselves. So the team like really pulled together. And I mean, that's really hard work and a lot of dedication.
Right.
And now that printer is doing incredible things. And now Ficos is printing full scale holes, no problem at all. And so a lot of the ways we learn about things that work and things that don't work is through these resident projects. It's a really immediate feedback loop for us.
One of the projects that I thought was really interesting was it actually is AEC related, but from a building kind of dismantling and recycling standpoint, right? Which was the computer vision nail puller, screw puller.
Urban
it would
machine.
take timber and it would scan the piece of wood, and they would have nails driven in at all different angles and screws, and they would be bent and they would be straight and they would be all over the place, just like you would find when I'm literally doing a remodel project next door to this room, and it's like if you pull out an old piece of wood, there's a bunch of stuff in there, and the recycling doesn't allow for mixed materials like that, right? And so the metal all has to be pulled out. Everything has to be cleaned off the wood. And so maybe you could just explain that project, because I thought it was, well, you watch it happen and it's like, wow, this is a super cool idea, and it's happening right here in front of us.
So that team is called Urban Machine. Also incredible team of people. My team and the person who runs the resident program got to visit their facility in Oakland, where what you saw was about, I don't know, a tenth of the size or
That's
12th
what I
of the
think
size.
You guys said that. This is a small demo unit, like not the.
And the real demo unit is 80 feet long. So what they're doing is taking lumber that is riddled with metal and nails and hardware, and because they're using computer vision, X-rays, cameras, they're able to find where the metal is on this piece of wood, clean it first, like it goes through this sort of like these brushes and this kind of like this grabber thing that feeds it through like on a conveyor belt. Mm-hmm. And then it starts pulling, like aggressively pulling out these pieces of metal. And
it's like a robotic pincher kind of a
that's
thing,
right?
It's almost like a CNC where it's on multiple axes, so it can get to these different angles.
And the end effectors that are pulling the grippers that are pulling all of the hardware, they're different kind of grippers because a lot of nails are bent, like nothing is perfect. And so it'll do a first pass, it might miss some nails, it'll do a second pass. Ultimately, it will confidently bring every piece of metal out, and then it will do a final X-ray, because like you said, you can't use any piece of wood that has any metal in it. Like people just simply won't allow it, to be sold. So what they're doing is some of this wood is old growth redwood, it's old timber, it's beautiful wood that you can't even get anymore. And so they're reclaiming it and putting it back into the economy so that so builders can choose from this. And also this is really preferable timber for a lot of people. But yeah, what you saw was a very scaled down modular version. The demo was just as impressive as the big one. It was just incredible to see what they were doing, but they bring that around to show people what's possible. And then, but yeah, they're on version 3 now, and they're getting a lot of business. People are really excited about it.
I can imagine that's a huge deal, because I'm lucky enough to live near several lumber yards that sell reclaimed lumber, and just to go look at it, like it doesn't even compare to the stuff that's being sold on the shelves of the big box retailer, right? It's not even close. And if you want to find something with character, like what's really cool is it's actually enabling this to happen, right? Because otherwise this is a very manual process, and you said it aggressively kind of grabs all these things and rips them out of there, but it's also like it's not hacking away at it to actually make that happen. It's so precise in the way that it does it.
The finesse is kind of remarkable, and how the wood looks afterwards, it's not all torn up. It's not, sure, you'll probably have to, run it through the joiner planer, like you'll have to process
Yeah.
it, but you're not losing lumber. And some of the grain on that wood that we saw on when we went to their facility, I just could not believe it. You just don't
Yeah.
see lumber like this.
It's a neat problem to go after, and it to me it like I would be interested to know like where'd that idea come from. What were they doing that led to that idea? And they're like, we'll take this and we'll solve this problem. I find that being an interesting story in this.
I'm sure that story is out there, so I would hate to
Yeah.
get this wrong, but I will say for people like Ficos and Urban Machine, it usually has to do with them seeing like there's a problem and it's
Yeah.
affecting like not just me, but the world writ large.
Yeah.
And
Yeah.
we have ideas and let's just try this out and see if we can make this happen.
So
So
when someone like that applies to be in your residency, do they already have a prototype or like what is the starting point that they're coming to you with saying, here's why we need your help to push this forward?
yeah, I would say generally nowadays because of how my team and the team like the work that we're focused on within Autodesk Research, I would say yes, we favor projects that are kind of well thought out. Maybe even if they don't yet have a physical prototype, they've really done a lot of engineering of or pre-thought about how something will be manufactured or engineered. That's really important. But like Kit Switch is another team I wanted to talk to you about. They're the ones who do that sort of turnkey solution for like kitchens that have like the whole range built in. It's basically they're making these modules that have everything you need to have a kitchen unit. And they had a fully formed idea in their minds and on paper about how they wanted it to work. And they had a lot of mechanical engineering experience, but didn't have the hands-on experience in the workshop. And they seemed like a
Okay.
really good group to come in. And sure enough, they were and they are. And but they learned a lot of hands-on manufacturing techniques here. And so they had a lot of like their drawings had all the hit all the marks, had everything they really needed, and they were thinking about things in all the right ways, but they didn't have that practical, physical understanding of how are these materials going to come together? How long does
Yeah.
this actually take? What tools and techniques should I actually be applying? Is this CNC? Is this handwork? Is this, if I'm
Yeah.
farming this out, how do I talk about this so that I'm using the right lingo for various, vendors? So they were a great example of someone who had a really strong proposal, but didn't necessarily have the physical output yet. But then from the work they did here, now they have a physical module to
Yeah.
show.
There's a big disconnect all in across many industries, right? Where the designing and the documentation doesn't take into account the years of experience and all of the practical stuff and material knowledge and tolerances, and there's a disconnect there, and we see it in architecture, especially with students, right? Because of course they don't have that real world experience. But I think the problem with even in architecture, just to get a little bit esoteric here, off the topic, is just there aren't a lot of opportunities to get out and look at it, go on a site visit, especially during every stage of the construction process, right? There are all the different trades. Like you'd be lucky to get out as an intern on one project site in the summer because no, you've got to get in, you've got to operate that computer, and you've got to get those drawings done. And so it's really difficult. So I think what's interesting about a place like this is that it really puts all of that together under one roof, plus the expertise that they can tap into of the people who are there, the other teams that are there, what's
Mm-hmm.
worked for you, what doesn't work for you, like what should I ask? What are the questions I should be asking as I embark on this project? Because those are the kinds of things that like you just can't get in the vacuum of just designing in the software, right? It's just not there. That connection isn't there.
Yeah, I fully agree. I'm definitely myself a hands-on learner, and it's one thing to read things, it's one thing to study a diagram. It's really a different thing to hold a block of material or to hear the sound of a cutter doing a facing pass, or, like it's really different to hear the vibration or feel the vibration of a machine and then understand, oh, okay, yeah, this is a really physical, visceral experience. And then I think it also gives you empathy for what it takes to manufacture things. I think it gives you a lot more respect of what it takes to make, like, even like the blue jeans we're wearing. I remember doing a sewing class once and I was like, oh my gosh, so much goes into one pair of jeans. We had to make a pair of jeans and it was a really hard project. And, they had to like be jeans. They couldn't be like avant-garde flotation denim moment, like it had to be actual jeans.
Real jeans. Work jeans.
Yeah, work jeans. And yeah, it gave me a really big appreciation of what went into things and the things we kind of take for granted. And I think there's a lot that's taken for granted about, all these everyday objects we use and
the cost even of the tools, let alone the experience to actually use them. But I think, one thing that I see a lot of people complain about how much it costs for a plumber to come do something, or just to or to create, like you're talking about, to create something, and not realizing that CNC machine is $250,000, right?
That's
like
right.
this is not simple stuff. This is not a circular saw that you can buy at Home Depot, right? Like that's the kind of things we're talking about. And then to manufacture things at scale, to really take that from the prototype level of 1, 2, 3 to 1,000 or 10,000 or 100,000. I mean, just thinking about my iPhone right here, right? There are millions of these, and the tolerance is incredible, and just what it takes to get to that point. And just to reinforce what you're saying about just kind of this underappreciation for what it actually takes to make real things. This episode is made possible with support from AVAIL. In a world where precision meets creativity, where every line drawn holds the power to innovate, people like you are shaping the future. But let's face it, in the realm of design, the unknown is your least favorite companion. You've been stranded on the island of inefficient software, lost in the fog of endless searching for the right content. It's time to embark on a new journey, a journey to clarity, efficiency, and design excellence. It's time to get off that island and away from the unknown. Introducing AVAIL, the beacon in your design odyssey. Say goodbye to the daunting 10 to 20 minutes wasted per search, the costly interruptions in your creative flow. With AVAIL, your team will zip through content discovery, focusing more on designing and less on searching. Imagine a world where you can stop constantly fighting the costly fires caused by pulling content from past projects, building from scratch, or relying on personal libraries. AVAIL isn't just a tool, it's a revolution for AECO firms. Organize, manage, and navigate your project information with a leader that's proven in reliability, relatability, and success. Join the ranks of the top AECO firms who've already chosen AVAIL. In just 30 days, you could deploy AVAIL and witness a dramatic reduction in costly design errors. Whether it's your first CMS or you're considering a switch, there's someone you should meet. Will Rouse, your guide to all things AVAIL. Schedule an appointment and explore AVAIL's capabilities, onboarding programs, and professional services. Don't let your designs be clouded by inefficiency. Clear skies are just a click away. Go to getavail.com/stranded and book a meeting with Will to start your AVAIL journey today. AVAIL, where your best design is just a search away. My thanks to AVAIL for supporting this episode of the Troxel Podcast. And now, let's get back to the conversation. How did you get to here? I mean, I would love to hear a bit of your backstory to understand like where you're coming from and why you've landed in this place and why you care about it so much.
I was in school for furniture design, and I've always been an artist. And I did an internship at the Exploratorium, which is a hands-on science museum. And I was a good welder at the time because I was making a lot of metal furniture that didn't necessarily even seem like furniture, but you would sit on it, or it would like, you'd be like, oh, my body's meant to do this. Like it was, but because of that experience in metal, I started volunteering at the Exploratorium, and I got put on a lot of sort of metal projects that were happening there. So I was working under an exhibit developer, and then he'd be like, I need you to machine this, or I need you to weld this, or, I'd come in one day a week. And then I was also working at a restaurant at the time. I was like putting myself through grad school, and the time came where I could like probably make a lot more money, working at the restaurant, which was a great group of people, or I could make no money and work at the Exploratorium, but probably learn a ton. And I chose to do that. And I really kind of feel like I grew up there. I worked with an incredible group of people from I feel like people who previously worked for NASA and NASCAR, like the breadth of work and expertise.
NASCAR. Yeah,
the breadth of expertise there was really pretty remarkable, and
that's cool.
And it was very mission driven. It was all about National Science Foundation funded grants that were making a difference in people's lives, and the shop was very close to the audience. So at the time when I started, I was working at the Palace of Fine Arts, and I don't know, I just really cut my teeth there, got a lot of machine experience, got to develop exhibits, and realized I really love solving problems through making things. And, the Exploratorium was pretty scrappy at times, but also we'd get these big budgets and we could make these exhibits that, needed to withstand a lot of abuse from well-intentioned but pretty aggressive like my target audience was always like a 13 or 14-year-old boy who's like going to a science museum and has a hammer, like how is this thing going to withstand
I've designed schools. I know exactly what, it's like this thing has to last 50 years with a bunch of 13-year-olds just breaking it every day. Yeah.
And so it really helped me understand too, like what is attractive to me about experiences that I'm expected to do something. And so I really learned how to sort of distill down things where there wasn't a lot of reading. Everything you were going to do made sense of why it was where. And, we did a ton of visitor testing, a ton of validation, and a ton of exploration on surfaces, and things had to be safe. And, you couldn't have something where you poke your eye out, or, all these basic considerations. But that led me to, I don't know, I worked there for a very, very long time. And at the time where the Technology Center, which was then Pier 9, just called Pier 9, my friend worked here, and she was like, do you know any women who know how to teach wood class and welding, metal? And I was like,
was she asking that rhetorically, or was
she was
serious?
Really flummoxed. And I mean, it's fair because I had a full-time job.
Come on.
I'm like, woman, you're looking at her. And so, at the time I worked 4 10-hour days there. And so I had a Friday where I could do that. And so I just sort of dipped my toe over here. And then I realized, oh my gosh, I have more energy after a 8-hour day on a Friday than I do. Something is really magical about this place. Yeah. And I love teaching. And so it's like a long story short, I basically had an opportunity to leave the Exploratorium in a way that was a great way to leave. I could do a volunteer layoff, and it was good for the whole organization. And so I was able to leave on a high note, and also someone else was able to stay, and that was really a valuable member as well. And then I started working here as just an instructor, and I was just teaching people how to use various tools in the wood and metal shop mainly. And then over time, I became the lead of the instructors, and then I started taking over certain other things. And then when the person before me left, then I was doing a lot of the things already. So I kind of understood, I sort of really understood how things were working here. And so I started managing this place as well. And I will say, when this place started out, it was the premier makerspace of the city. And, makerspaces were really big. And the mission was just so different than what it is now. And now I would say we're a really incredible showcase of like for small and medium scale manufacturing businesses who want to understand like, okay, so how do we safely bring data in? How do we use robotics without making it scary for people or for them to not feel like their jobs are being threatened? Like, can you prove this out for us? Like, basically, we're the proving ground. And I think that's what I wish I said a little earlier in the introduction. You know, it's like just we de-risk a lot of things because we try things out here. We show how it can be done. We show where the pitfalls are, where workflows can be made more seamless or easier, and we do that by using the workshops. And so we've divested of a lot of the sort of makery equipment over the years. Plus, you know, once equipment gets old, it's no longer as shiny and new and effective. And so right after COVID, when we were coming out of COVID, we did a huge shop refresh. So we brought in a lot of equipment that really reflects more the state of the art of manufacturing facilities. Mm-hmm. Did I really answer your question? That was a really long answer.
Yeah. How you got to where you are. Absolutely. And it seems like a perfect fit. I would love to talk a little bit about the research aspect of this, because that really seems to underlie all of it. It's not just learning how to use equipment or how to bridge the gap between design and manufacturing, but there's this kind of test and prove, ask questions, use data to make decisions. Can you talk about that layer of it? Because when I go down to my shop, like, okay, what I'm making is likely a prototype, but all of architecture is a prototype. Like every building is a prototype, right? So that I don't think about it from a research standpoint when I approach a problem. And I think that is just something I would love to hear more about from your perspective of why is that the basis of the way you operate? Obviously, you're using this to inform your software and how it communicates with machines and all this, but I'm sure it's much more than that.
Well, so there's a lot of different groups within Autodesk, of course. It's a very big company, but the umbrella I'm under is Autodesk Research. And some of the projects I can't really talk a lot about in detail because they're horizon projects, 5 or 10 years out. There's research papers that are being written, or, you know, there's all this research that's being done on these various projects that you'll see it in a few years. But the technology centers help support the work of that research because we are the physical spaces where we can prove some things out. But there's explorations in sensorization of vessels. There's a lot of material studies for architecture. There's things that are being done where there's sort of small scale experiments happening, and then partnerships with larger companies who can really help scale up and take some of these hypotheses, and then, you know, we're doing a lot of the work here, and then once we validate those tests, then we can get them manufactured at a larger scale. You're going to talk, I think, a lot in depth about Project Phoenix and the collaboration with Factory OS. So that's one sort of research project that was pretty under wraps, and now it's much more public. But that's sort of where we are now in research. There's a lot of different focus areas: adaptive robotics, doing complicated assemblies with computer vision, with machine learning.
You come from a maker background, and you don't.
Yeah.
Do you have a research background, or is this something you picked up along the way? Because it does seem to be like the way you're explaining it is like that is a thread that hits every single project that comes in, because the whole idea of prototyping, validation of ideas before prototyping, testing, iteration is all based on kind of this research mentality.
Absolutely.
Yeah. So, and I don't think that happens in AEC as much, right? It's so that I'm interested in hearing about this, because on the manufacturing world, which you're much more focused on at this facility, that seems to just be the way it's done, at least the way that everybody that comes through your place is approaching projects, versus us, it's like, I think AEC is much more interested in doing it the way we've always done it than it is about researching and iterating and finding new ways to do things. Obviously, there's a small
Yes.
percentage of people in
Yes.
AEC
Yes.
who are interested, but for the majority of us, no, it's like, no, this is tried and true. This is best practices. This is,
And this is
we've
going to be
always done it this
faster.
way.
Yeah, exactly. Like it'll take forever if we do it this other way, but
We can't learn anything new because we can't spend the time to do that. Right.
it's too expensive. Yeah, but the problem is, as we all know, like the planet is finite. The resources that the Earth has are finite. And so we have to figure out different ways to do the things we've done for years and years and years. And there are some of these research focus areas that are geared towards sustainability and materials in construction. So yeah, there's some teams working in the AEC space that are really trying to do things differently than how they've always been done. But it's interesting because not until you said what you said, I've never thought of myself as a researcher, but yeah, I had to do tons of research before I developed an exhibit. I had to know what I was talking about. I was at a science museum, and like here, yeah, you have to do tons of research before you can, whether it's, figuring out a workflow or it's understanding the material properties of, understanding how machines work, understanding how this group's going to work with this group. Like there's a ton of research that's involved. And so, yeah, I think I'm in the right place here. This makes a lot of sense.
So has that changed your approach over time? Because it sounds like you weren't always like that, and now you are, right? And so I don't know. That's the question: has this changed your approach? Because like my wife is a researcher. She has analysis paralysis, right? To that extent, where it's like, well, we could do this or this or this or this or this, and I'm like, let's just pick one and try it. And so I'm much more of a prototyper, or just jumping right in. And obviously, I would love to hear kind of your experience with that, and maybe what are the benefits of those changes over time, if that's really what's happened.
Well, I manage a team and we have to get things done. And so I think I sort of straddle both because I have my eye on what the deadline is and what needs to happen. And so at some point you have to put the pencil down and you have to actually stop theorizing and start practicing. And my advice to the team I manage and to myself when I'm listening to myself is stop thinking, start doing. And it's through making mistakes where it's great to make mistakes. The mistakes teach you so much. You learn so much more than when things go perfectly. It's not good to make the same mistake again and again. No, we want to avoid that. But those mistakes are hard won, and that sort of builds that tacit knowledge that becomes so valuable when you're working in the workshop and with other people. And that experience becomes so valuable. That knowledge becomes so valuable when you're sharing what you know to to fellow researchers who maybe aren't getting their hands dirty. And it's all valuable. What every person is contributing is really valuable. But when there's a physical artifact, I say get to the materials sooner. And no, don't prototype at full scale. Don't prototype in the most expensive materials there are. Really distill what are you trying to find out? Because if you are just going on assumptions and researching, sometimes there's just a fear of like, okay, I'm going in the shop, I'm going to make some mistakes, it's going to be a disaster. But like that disaster, suddenly like 6 hours pass and you're like, oh my gosh, I just learned a lot.
Yeah.
Never do that again. Going to do more of that, like.
Totally.
So yeah. Because I come from this world where I think I could be in my head a lot, but also I had a lot of, I have a lot of deadlines all the time, and that, juggling multiple projects, you can't just only have one baby. You have to have a few irons in the fire because inevitably they're not all going to work out, and you have to sort of be able to pivot. And sometimes, you'll do one process, it takes time to either cure, or it's printing, or it's sintering, or it's doing some process where you have to pivot and change gears and do another thing. Or you can't just sand a piece of whatever it is, for 10 hours. You need to break things up because you'll either go crazy or, your brain can't do that. So
right.
I think I like to encourage people to be nimble and flexible, and also like the 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 targets change. You can't be so stuck on certain outcomes. And sometimes, and I think this is the beauty of research and the research that's happening here, sometimes you make these discoveries and it changes the course of what the research becomes. And
Right.
I think that's a really powerful thing that's happening here, is that people are really attuned to these small discoveries that could change the course.
Yeah.
Yeah.
This episode is made possible with support from Confluence. Picture this: October 2019, Lexington, Kentucky, the birthplace of Confluence, a place where tech leaders, AEC product developers, and practitioners came together for 3 transformative days. It was more than a conference. It was a confluence of ideas, discussions, and unforgettable social experiences. Since then, over 200 attendees have experienced the magic of Confluence. I've had the privilege of being part of 3 of these remarkable gatherings, 2 in Kentucky and 1 in Orange County, each one a melting pot of learning, collaboration, and camaraderie around a topic shaping our industry. And now we're thrilled to announce the next regional Confluence event in April 2024 in the vibrant heart of New York City. This time, we dive deep into the realms of AI and machine learning, unraveling their mysteries and potentials in our industry. Are you interested in being part of this exciting journey? To continue the conversation, to shape the future? Visit the link in the show notes for more details. Confluence, where ideas flow, connections form, and the future of AEC technology is shaped, one conversation at a time. My thanks to Confluence for supporting this episode of the Troxel Podcast. And now, let's get back to the conversation. One of the big messages at Autodesk University this year was the design and make platform. And obviously, this is what we're talking about here, like where the rubber meets the road. It's actually happening. And I think one of the big question marks, especially in the AEC sphere, was like, what do you mean design and make? Because there is a disconnection between design and make, and the feedback loop is difficult at best when it comes to that, because there aren't a lot of design builders. There's a lot of architecture design and design firms, but there's a handoff in that process when it goes to a contractor to actually build the thing. And then there's not a lot of incentive to share, at least perceived incentive, to share that information, which obviously would benefit the whole process, right? Because if you can take the stuff that happens from the hands-on experience and apply it in the design process, then it makes the implementation process much more smooth. So that's obviously what's happening here, right? Is you've created this feedback loop and you are actually making good on this design and make, marketing term as it is, but it's also kind of an ethos. And so maybe you can just talk about that at Autodesk and what that means to you.
One example I can think of, or that you've gotten me thinking of, is relationships that we have with equipment manufacturers. I think a lot of people assume that, company like us, we buy a piece of equipment, we write the check and we say, okay, bye, thanks. And maybe there's a technician that comes out.
Right? It's
and they come out, they commission the machine, we sign a paperwork, and then we're done. But the relationships that we have with certain equipment manufacturers are so critical and are so important to the ecosystem and how we get our work done. And I really credit my boss, Adam Allard, with instilling this in me and my colleagues, where this is not just a one and done deal. Like they need to be accountable, and we need to be accountable to them. These are relationships that we want to have over the long term. So we need to have a really good rapport with them, and really authentic rapport, and be able to flag when things aren't going well and to celebrate the wins. And with Mazak, we have this incredible 5-axis machine that you saw when you were here last year. It's a hybrid machine, so it's the first of its kind on the West Coast, which is a big deal for us, and it's the third of its kind in private hands. They have one of these at Oak Ridge National Labs, who we have a relationship with and talk to a lot. But with Mazak, what we really wanted with bringing this machine on and what they were curious and interested in is having a machine that people could see and see showcased when we're giving tours or people come by or we do these interesting projects for Autodesk Research. And so our relationship is so strong with them because we meet with them on a biweekly cadence and we report out on these are the things that are going really well. These are the things we need some help with. This is the post that Fusion needs in order to make this better, that then everyone can use it who's doing 5-axis machining or hot wire deposition. So like we have a number of people on the call from different parts of the company who are making Mazak's product better and Mazak's making our software better. So it wouldn't happen without these real relationships or like, hey, something's going on. Okay, check this. Like we have them on speed dial and they can just talk to us. Like they're great partners because we have real relationships with them. So
and you're actually using that equipment. Like it's actually
right.
in use in your facility. It's not like you're hearing this stuff secondhand from your users who are just using your software who have that machine, if they're lucky enough to have that machine. But it's like really hands-on kind of feedback loop that you've generated.
Yeah, that's right. And I think what's very cool about this space as well is that, I can say same thing about Renishaw or about Haas or about Mark Forged. We're not just focused on one group or one vendor. We it's part of an ecosystem when we're telling a bigger story. And when we have wins and the machine is doing great things, we're going to feature that. So that's a win for them because it's like good press for them. But we're not telling stories we don't believe in. And for me, and managing this space, it's really important. Like the health of my team is really critical to me. So I don't want someone who's constantly having to manage fixing something that's always broken. Like that's not a good machine. That's not a good story to me. So
yeah.
I'm constantly seeking out the things that are going to work better. Of course, all equipment needs love, but I want the equipment that you give it some love and then it really sings for a while. Like that's what I'm after.
I think you just titled this episode right there. This all machines need love. So where does this come from in Autodesk? Do you know the story about where? Because obviously, this whole the investment and the actual R&D, or not the technology centers that you have, they really matter to Autodesk, obviously, or it wouldn't. But it's gotten to this point, and there's a history there. Do you know what that story is? Can you share that?
I think the Technology Center in San Francisco really grew out of the former CEO Carl Bass's love of making things, and he wanted a place where, and I think he really understood the great value of being able to take 3D to or 3D drawing to 3D object, like the virtual to the real. And so I think it started from there. He's no longer, the CEO, and we've really sort of changed as a company, but I don't want to give you the wrong answer, so I don't know, but I know that that's when I came on, and I remember being like, whoa, that's the CEO of Autodesk, just on the lathe making a baseball bat,
Yeah.
Incredible. Or he's making a go-kart for his son in the, this is amazing. He really loved, and he has an incredible shop of his own now, and, he's doing amazing things. And, but I think that he really understood the importance of like software to reality. And I think that's just
the physical, right? Yeah. Like
digital,
the actual.
Thank you. Digital to physical. Do I work here? Right. Yeah.
Well, there's a saying in architecture that is, if it doesn't get built, it doesn't count. Right.
Wow,
and so,
right.
I mean, that makes sense, I think,
Yeah, sure.
because it's like there's a difference between real architecture that people actually inhabit, and that's why we do it, is for those people, versus paper architecture, right? And so bridging the gap between digital and physical is a real hurdle to get over, and that can be that is the difference of what makes a firm that does real architecture versus
Sure.
a paper architecture firm, right? So for you, and getting back to that, when I brought up very early on in the conversation, that book, the shop classes Soulcraft, like, and because it really talks about the value of this work and the meaning. I'm just interested from your perspective as we wrap up here, like what is the value to you? And obviously you're running this amazing facility. You've got an amazing team. You're on a mission. You are all on the same wavelength and purpose when it comes to that. And again, this is kind of where the rubber meets the road between design and make and all of that. So what does that mean to you to physically be making things and helping other people make things for the physical world?
For me, it's a very empowering place to be because there's a lot of insight that comes from seeing something that's digital or digitally rendered and then actually getting it to be something that's physical, that's something that has heft and weight and is cold or warm to the touch or soft or sharp. It's one thing to draw a radius, it's another to be so glad that radius is there because now you don't have a cut, because the edge is so sharp.
Right.
There's I don't know, I think there's just this full body experience of it's amazing to be able to create these things with digital tools. Like we can do so much because of that, but there's so much that goes into between that drawing. There's so much understanding that goes into, from CAD to CAM. Like the human is the person that's instructing how you get from, you desire this plane, and so what end mill are you going to use to get there, and what's the RPM, and is there coolant? Like there's all of this stuff that then when you get on the actual machine, you're like, oh, wow, that's a lot of coolant. I can barely see what's going on. Or, oh, that's really fast. Or, oh, there's chatter. That's really dangerous. Like you start becoming way more attuned to what's going on in the world and like the things you take for granted. Because, if you're curious, you might say like, I wonder how they manufactured that. Or, oh, look, there's a seam line there. Was that,
Right.
mold? Like, was that machine? Like, I look at my iPhone all the time. I'm like, that's ingenious. Like, how did they get there? So, I don't know. There's something just constantly rewarding about being in a space where you can validate assumptions physically. I just think that's, and it's always, I'm a hands-on kind of learner in person. So it's my happy place personally, but yeah,
it's interesting to see it happening at such a, I mean, it's obviously a very expensive facility. The equipment that you have in there is but this does trickle down over time to people like me, right? Where I've got a shop and I want to be in control of being able to make my own things. Part of that's just because of the way I'm wired. Part of that is like there's nobody else around here who can do what I want because they don't have that vision or the tools to make that vision or the time to invest to learn software to make that thing. I just met a guy the other day who's a welder who bought his own CNC machine because he bought a historic house from 1902 and he's going to put in a spiral staircase and he wants to actually carve with this CNC machine the balusters that go up this, and it's going to be very intricate. And like what's really interesting to me is that it's a historic house. He wants to make it look and feel historic, and he's using completely modern tools to do that. But most importantly, like it's just he's in control of all of it, right? Like there would be value in having a true crafts person come in and carve all those the way that they were originally carved. And I'm not trying to play that down at all, but this is something that like every night he's going to make 2 of these things for the next few weeks, right? And he's going to go through prototypes and he's going to test it and he's going to try different mounting styles and he's going to try different wood and he's going to learn all about different bits and radii and all of these things as he's doing this and come out the other end with a huge value and purpose behind it all. I think that again, I keep going back to this book, but it really talks about these ideas of the value of doing this kind of work. And again, we live in a world that's very disconnected from that entire process. And I'm just happy to see places like the one that you're running enabling a different way of working to actually manifest things from digital to physical in the real world for amazing purposes. And the way that these companies come to you with proposals, and they want to be a resident in your facility to do bigger things that make a bigger impact, but through actually making real things that do that. It's not just software running on a server somewhere.
I probably should not say anything because you want to wrap up, but I'm thinking about the Mazak again, where suppose you have a casting and it breaks, and they don't make this casting anymore. It's from an old piece of equipment, but it needs to have this precision part to it so that something goes through it, and there's no way to really chuck it up on a big, or it would take too long to try to put it on a manual mill or lathe or whatever you needed. So with the hot wire deposition machine, you could basically, build up on this casting and get a near net shape. So it's almost what you want. And then you can machine it. So you're doing this additive and then subtractive in the same work envelope. And then your casting is as good as new. And so you're not, I don't know, your machine isn't just taking up space in the landfill or just being scrapped for parts. You're actually, there's this idea that we can use these technologies so that we can rebuild things that just need a little bit of, a little
just
kick, a little help.
Thing you can't get anymore, anywhere. Yeah, there's no new old stock.
And that's the power of being able to design all these things. And then the more you know about, if you don't know something exists, you can't think in those ways. And so I think a lot of what the technology centers do is have this equipment, and these resident projects kind of showcase use cases that maybe research isn't aware of or thinking of. And it helps inform the research they're doing. So it's a great proving ground and testing ground. And, mistakes are made. And also there's a lot of successes that come out of, look what I learned from this mistake, this is.
And then sharing that out.
Yeah.
That is an incredibly valuable process and place to be. So I'm looking through my questions, and I think you have answered everything that I wanted to talk about. Is there anything else that we're forgetting here?
I don't think so. I was so nervous, Evan. So this has been so nice. Thank you for being such a great host and conversation partner. This is awesome.
I appreciate you coming on the show. Is there anything that you've made recently or that really stands out to you? It doesn't have to be recent, that you're really proud of, that you feel like is kind of indicative of, because you've inspired me to get into my shop. I actually had to run power to my shop about 300 feet, and that was step one. I got there. Now I need to actually get in there and lay it out. It's a design process that I'm about to embark on. And there's going to be a lot of failures. One of my favorite YouTube channels recently is watching Adam Savage's Tested, because he just redid his shop. He's probably right down the road from you in San Francisco. But it's just this incredible place to make things for the physical world. And I'm just re-inspired. And by talking to you, I am. Is there anything on your side that you've made or that just really shows off what's possible?
Well, I just want to give a shout out to constantly learning things. So I wanted to get more 5-axis machining experience. I have a person downstairs who can help me with certain things, but I ended up taking a class that a friend of mine was teaching, and I was just nerd, studying all the time. Every time as soon as I'd go home, I'd be like, okay, I'm going to try this. And I was, there was tests and there was machine time. And I made this hammer that was in many parts using a lot of different machines, and a lot of the machines we had here. So I was very familiar with a lot of the workflows, but that felt really good to, I don't know, sometimes, you wonder, can I still learn things? And you can, but it was really comforting to know that, my curiosity led to follow through of something that was, it was challenging at times. So I think I just want to give a plug for like constantly be challenging yourself. And yeah, I felt very proud of doing something like that. And it makes me just want to get on Fusion more and play around more. And yeah.
There's this idea that I'm playing with right now as a topic for a future talk, but it's the importance of a side hustle. And you said the word curiosity there. And I think a side hustle is kind of taken on it's kind of a, people don't like to talk about side hustles because it means more work in a lot of people's interpretation of it, right? And we need enriching experiences outside of work, because I think the thing that you were just talking about actually informs approach, it informs projects, it informs your experience and how you talk to people, and it's brought inspiration maybe back to your job. And there is this kind of feedback loop
right
between the parts that make us up, right? So there's like work life, home life, but hobby life, side hustle,
right.
whatever you want to call it, right? Where that curiosity, can I even still learn things, right? That's a great question to kind of, again, go into the proving grounds and see that you actually can, because it reinforces who you are, but also it enriches the other parts of your life. And anything back, if I throw that out, like the importance of a side hustle, what do you think?
I mean, definitely. I have a studio outside of work that I go to, and that's, how I spend my time when I'm not at work. I also really understand the value of like rest and, reading and, music, and but I think that what's so interesting when you maybe have this side project you want to do, or something that's going to be, oh gosh, it's going to take a long time, or I don't actually know how to do that. But for me, at least, when I start that process, it's so energizing. And then suddenly I'm like, I can't get to sleep, but it's not because I'm stressed. It's because I'm trying to work out problems. And I'm like, oh my gosh, it feels so good to have that part of my brain flexing, and then you start, someone comes with something at work, and of course, there's something that they're working on that then sort of gets you to think about something else that you're working on, and then you can have this conversation. Dots. Yeah, right. So I think that's like super generative and really productive and a really positive thing. So I believe in a side hustle, and I believe that you should keep your brain active in other things, and I think it can only lead to good things. I also really believe in rest. Sometimes you just got to quit and you just got to recharge. I think that that's important to do too, because it's Absolutely. All, you have one body, you have finite resources. So
you're lucky. You get to work with some incredibly talented people, some of the smartest people, I'm sure. And that is, I'm lucky as well. I get to talk to people like you. I get to have people on the show who talk about what they're passionate about, what their purpose is, and all of those things. It's inspirational to me. So thank you so much for taking the time to have this conversation today. And I'll have links to where people can connect with what you're doing and you on LinkedIn as well in the show notes for this episode. And
okay.
Is there anything else that you want to point people toward that they should know about when it comes to Autodesk research, and besides maybe just the basic web links? Is there anything else?
Yeah, no, I will give you the links to the teams that we talked about, so people can do a little more research if they want.
Fantastic.
Yeah.
All right. Well, thank you, and I hope to talk to you again.
Thanks so much, Evan. Bye.
Thanks to our sponsors, and thanks to our members this week. Find out how you can become a member at trxl.co, and I'll talk to you again next week.